Good now. Oh, now it works. All right. Well, first of all, thanks everyone for coming back from lunch to listen to my talk. I was asked to give a short talk on updates on the Nerves project, which is near and dear to me, and there's a lot that happens, so I'm going to miss a lot. But first, I want to just get a check. How many Nerves users are there out there? All right, how many people are interested in using Nerves? Okay, all right, good. I'm not going to ask the last question. So, for those of you who are using Nerves, I hope to give you an idea of where a lot of us on the core team are currently focused and where we're going to be focused in the future. For those of you interested in the Nerves, interested in trying Nerves out, probably towards the end, I'll get to some improvements that will be more useful for you. And if you're totally disinterested in Nerves and you just came here anyway, maybe one of these things that I say might be possibly interesting to you, and hopefully maybe give you some thoughts to think about this whole side of Elixir that's being used in embedded systems. That's in addition to all the other things I think most of you know that Elixir is being used for. So, all right, who am I? Been working with Nerves for a while. I think it's going to be almost 10 years. Smart Runner, which was said, been a happy member of the Beam community for also, and then Runner, and then the Marylander part will become more obvious in about an hour, I think. All right, so for the set of you who haven't used Nerves, let me give you the high-level view before I dig into all these details. So what the Nerves project does is it provides these tools that let you take your Elixir code and turn it into one binary that you can put on a little piece of hardware that you can place anywhere that, and turn on lights, control systems, do pretty much anything that you might possibly be able to think of. But the important part is it's on this small single-purpose piece of hardware. So if you've heard of Raspberry Pi, that would be one particular target that we go to, but there are many others. So I used to say that this is all on easy-to-buy hardware. The past few years have been particularly tough, but we have a few dozen options if you're looking for hardware. Companies many times make your own. If you are having trouble finding a Raspberry Pi, there might be a friend perhaps, who can loan you one. Maybe it will get a little bit better. The other side, the core team maintains a set of libraries that are useful across the board with Nerves. So we don't, the general Nerves community, the Elixir community provides a lot of libraries which people use when they build their systems. We provide some of the core ones. And last, and this is not the least part, that when you build these embedded systems and when you deploy them out to the field, one of the surprisingly hard problems is how do you get software updates out to them? And we provide a couple options for doing that. There are others that you can do as well. So that's it. Why use Nerves? It's the Beam. It came down to the Beam. That's what got me started with it. That's what brings, I think, a whole lot of people just to even check out the project. I think many talks will go into that. But let me just tell you the other thing that's a real superpower for Nerves, and that's Elixir and the Elixir community. One, it being a fun programming language, very enjoyable one for many people. It's an enabler for a whole lot of people who, for reasons, either be it interest or work, just need to start doing some embedded programming for themselves or their company. The Elixir ecosystem, in particular, is very interesting from embedded systems programmer's point of view. What was done on OTP was to give a set of structures that basically people write their libraries along. A lot of Elixir libraries, Erlang libraries, follow that structure. You can think about how you handle air conditions, how different libraries interact with each other in almost the same way, especially if you're coming from a traditional embedded place like C or C++, where you're integrating a lot of disparate code. The Elixir ecosystem is a little bit easier to comprehend and kind of figure out how things interact when you start putting a lot of functionality on the edge. Let's see, that's it. And then the other thing is this isn't new. Like I said, I've been doing this for a while. Nerves has been deployed in a lot of different areas. I just put up a few. I don't have pictures this time in this presentation, but I think Early on, there was one of the first ones was in the marine on boats that the Elixir was being used there in the control systems. FarmBot, a lot of people know about the robotic system for growing crops, but there are other farming applications, and then of course my company uses it, and many others. So when you go to Nerves, it's not like you think about risk. There are areas of risk, but there is also a lot of stuff in Nerves that's been proven in production. All right, now we get to the whole point of this, which is what's new. And I'm dividing this up into, let me just get this out here. There have been several projects that have been used enough to find some issues, some improvements that could be made. So I put a list of 2.0s. So you're going to be seeing some API incompatible projects that are being done that way for a reason. The second area that I wanted to comment about, and this is Livebook and machine learning. So I think a lot of you know NX and have been watching this, and there's been just a crazy amount of progress in this area. Nerves is definitely, starting out on some of this, but we have some work in that direction that I wanted to share. And then for those of you interested in using Nerves, I think we have some updates to the website that are going to help you out, and I wanted to make sure that you all were aware of those. All right, so I totally lied. There are things that we do real quick all the time, Erlang updates. And just real quick, OTP 26 is coming up. Jose Valim went just to town on optimizing a couple things that end up benefiting Nerves a lot on boot time. That's an OTP 26. We'll hope to get that out real soon now so that we can start updating applications to use them. No one will see these except, you'll notice performance improvements just magically happen. Next one, Linux. So Nerves, without getting into the details, Nerves uses the Linux kernel. It's a very minimal system. The Linux kernel is from my point of view, a great piece of code to be associated with because there's a lot of device support. There's a lot of libraries that you can pull in. If you're building an embedded system and you need to use some random piece of C code or whatever that comes with your domain, there's an option to just put it and run it with Nerves. And that works right out of the box, and it's interesting when you can't rewrite everything from scratch. So we do those. And then new hardware. This first one I've talked about a few times before, MangoPie MQ Pro. It's a RISC-V, so Nerves had been just ARM processors. Those in x86, so different architectures. RISC-V is a really interesting one for me because of its open source heritage. And seeing some of the innovation come from people building processors and building silicon, being able to integrate in these new little features into their processors that can do special things. And I think over the coming years, we'll be seeing a lot more RISC-V, and Nerves is already running on at least one of them. This next one, BeaglePlay, BeagleBone users out there? Maybe, yeah, there are a few of you. BeagleBone was a open source board like our hardware board, similar to Raspberry Pi. It got put into a lot of hardware products that run Nerves. So BeaglePlay's next iteration has some neat features. There have already been some updates to the Nerves core libraries to support it, and we'll hopefully get official support out for the BeaglePlay soon. All right, now back to I didn't want to do that one quite. So now for the 2.0s. And I've ordered these in the order of least interesting, probably to most of you, to most interesting. And this first one is going to be the least interesting, but totally the one that's the most interesting to me because it's caused the most pain to me for the longest time. So I'm just going to take up a few slides and just share you some of this interesting little piece of code way down underneath everything. So anyway, the prep for this is you all write gen servers. You have supervisors. Who supervises the supervisors? So you might throw out some answers. Not systemd, but eventually it goes somewhere. Then there's a little piece of code that some of you may have enabled called Erlang Heart. And so Erlang Heart is, you start up Erlang -heart, and it has a little C program that basically Erlang or Elixir has to say, I'm okay. And it keeps on saying, I'm okay. As long as it keeps on saying, I'm okay, Erlang Heart's happy, and that's good. And if you stop saying okay after 30 seconds or a minute or whatever you set it to, Erlang Heart says, nope, shut down and restart. Shut down Erlang completely, crash. So on in-a-bit systems, we have an additional kind of supervisor-like thing called the hardware watchdog. And this is kind of the same idea as Erlang Heart, except made in a little piece of hardware. Sole purpose in life, like just, not many transistors, sole purpose of life is to be told, I'm okay all the time, and if it's not being told I'm okay, to reboot. And I think a lot of us have become kind of comfortable with like the Erlang and Elixir solution to many problems is just restart, right? So why not do the same thing at the hardware level? And that's this, the hardware watchdog. So we have this little program that we wrote for Nerves called NervesHub. And NervesHub did this, replaced the Erlang Heart, but also pet the watchdog. So it did this, and all good, right? You're right. We ship code out to the field. Something goes really wrong, and maybe Erlang Heart, NervesHub doesn't catch it, but Linux kernel hangs, and then eventually the hardware watchdog kicks off. And great. So here's the URL if you want to read all the gory details. What we found out through the past few years that there was missing coverage. So there were parts that you could get a device on the field that was vulnerable. And of course, you'll always learn these things the hard way. That NervesHub would think everything's okay, and it clearly wasn't. At least all the little areas that were not covered, I think are covered now. We will learn the hard way again if there is some additional work to do there. Better status and snooze. So what snooze is, you have a device somewhere. So you just have to imagine that you just don't have physical access to your device, and there's no one there, no human being there to help you out. And you're logged in remotely because you have support for that, and you're trying to debug, and it's just misbehaving, you just totally don't know, and then Heart goes off because of course it's misbehaving, of course it's going to reboot, and you're trying to debug. With snooze, that puts the pause on that for the next 15 minutes, so you get some more debug time. So that's those are the main things. Let's say this thing already has even new things, so without giving, or NervesHub already has some things that will be coming soon. I'll just give a teaser. Window Watchdog is coming, and also things like Beagle Play has 7 hardware watchdogs. So anyway, come after me if you are interested in hearing about that kind of craziness. All right, so next project, Elixir Circuits. How many of you have used Elixir Circuits? All right, so the gist of Elixir Circuits, I have an embedded device. I have a whole bunch of things. Whatever. How do I talk to them? Elixir Circuits provides the answer for I2C, SPI, GPIOs. These are kind of the words that when you get these hardware devices, they have like a little protocol dock, and it's basically sending bytes back and forth to these things. And the bytes are usually simple or maybe more complicated. And the transport for this is the Elixir Circuits library. So the 2.0 pre, because couldn't release it today, so it's there. You can try it. The key feature for this was it's no longer just Nerves and Linux. And why is this important? Because this has been with Elixir Circuits and its predecessor have been around for, I don't know, I think like 13 or 14 years right now. So it's like it's in their Erlang roots. It's like basically the same API that's just keeps on progressing, and we've done optimizations and all this other stuff. But it's always been tied to Nerves and Elixir. Can't use it anywhere else. That finally, our community's finally grown to the stage where it really was starting to hurt. So the idea was we'd have a swappable backend, so you can do this. It's if you're not using Nerves or Elixir, you don't, or Nerves or Linux, you don't pay the price for the Nerves and Linux backends. You can swap it out at compile time when you build it. But this enables stuff like, I have unit tests, right? I have some temperature sensor. I want to be able to see my program, communicate with it, and not mock it at some inconvenient layer in the API. Well, this is another way. I want to develop, like, past couple of years. I want to develop on anything, and I can't buy a Raspberry Pi. Why can't I just develop on my laptop? And then so people made these USB to I2C adapters, and so you could do that. I mean, Elixir Circuits couldn't support it, especially if you had a Mac. So now there's a prototype for that that can be tried. And then the other thing that's been happening is that there are two other embedded systems projects, GRISP and Crichton. So GRISP, I think, has been around, mostly focused on Erlang community, but still can do Elixir, and you can still run a lot of Nerves-related projects on it. Well, this now adds one more. And then Crichton is a really interesting project. I don't have time to go into it, but definitely search this out. It's taking the Erlang VM and putting it on a secure operating system or a small microkernel. It's really cool. And the Crichton team had contacted me about how do we share Elixir Circuits, and this is a way. And let's see, getting to my favorite one, Circuit Simulator, which is kind of getting back to this mocking of the back ends. So no hardware at all. I want to do it. And here, I can actually just show you. It's just easiest. Just imagine no hardware. This is just my laptop. What the Circuit Simulator does is let you say, in the configuration file, just say, I have these devices connected virtually to my system. So if you're an Elixir Circuits user, what you do is when you have some new device, you're like, okay, I want to detect it. And this is so with real hardware, it would go send messages across the bus to find it. It does the same thing virtually. And the enabler on this is that, I have all this code. I can either use it for unit tests, or I can just get more insight into what actually happens without buying a logic analyzer or any of the other things that hardware engineers typically do to give insight to the magic that happens on that wire. So in this little demo, that little device at address 56, that's basically what it says, is this thing called the AHT20. The AHT20 is this temperature humidity sensor, and this isn't a library that I wrote. This is a library, just get it right off of Hex. You run it, and it starts. The library doesn't even know better. The library wasn't even modified to support the simulator. So it's just doing all this communication with it, and you can even do things like the main call to this library is to measure, and it will report back to you some simulated temperature. Some of the simulated components, you can actually change temperature. Yeah, I know. So Amos is kind of excited about this. I think you've been wanting probably something like this for a lot of years. Yeah, we won't repeat that. Thank you for being patient. All right. So the third of the 2.0s that I want to just share with you is this not embedded project called NervesHub. So this NervesHub is a Phoenix project. And why do we have a Phoenix project? Well, this is partly to solve this whole firmware distribution problem that we have. You can imagine NervesHub being a Phoenix project in the cloud. All of your little devices connect to it. You have a laptop, your laptop you can connect to it. You can do things like get to the IEX prompt on any of these devices. You can send new software to them. So I actually made a little animation to that. So first, you load up the signed software. So there's cryptographic signatures. There's a lot of work that this is abstracting over. But essentially, you get it over there, and it will send firmware updates through some means and ordering to all the devices out there so you can get the latest and greatest on them. So that's it. So I had to have a slide on what we learned, and this is going to be, I think I'm going to leave you all like wanting to know more, but I just didn't have time. So I just want to hit some things that are like top in our heads when we start going on why we want to do a 2.0 NervesHub. And the good thing, since I have all these other things are bad things, the good thing is that remote IEX. Remote IEX has been like such a game changer to, I think, everyone. It came as like this random feature ad that we did when we first built the system. But since then, we have rescued devices that are dead by like logging onto them. Now we even inject code into the devices on connection. So if a device like only lasts online for like a minute or two, like we can inject code to fix whatever problem is causing them to be a little bit sketchy so that it can be fixed with the firmware update. All right, the next thing on this list is TLS. If you've dealt with TLS, we use the Erlang TLS stack, which is great, except what we found out is that there's different compatibility levels between Erlang releases. So what tends to happen with embedded is you end up building up a warehouse full of devices, right? So we may place an order, we get a whole bunch of devices, they're in the warehouse. Maybe it will take a few months to get them released, set up and put in the field. Maybe it will take a year. So what we end up having is like OTP 23 running, on some device in there, and then all of a sudden we've updated NervesHub to OTP, let's say 26. Not everything's compatible. If you want to know the full details, go to the NervesHub website, because John Carson's built this huge matrix for the compatibility, and spent like a ton of time figuring this out so that the rest of you don't have to. Another thing I want to mention, MQTT versus Phoenix channels. NervesHub is Phoenix channels first. We're having a lot of pressure to switch to MQTT for reasons that are not necessarily technical. These are just things with how organizations want to distribute or want to build their back ends. There are some technical things that help with MQTT. It's not the things that I thought going into this, which was like saving bandwidth or a lot of these little improvements that MQTT has over Phoenix channels. So NervesHub 2.0 will be getting this. The last thing, just-in-time provisioning, which this will probably, only a few of you will probably care about this. If you're the ones if you know these words, just-in-time provisioning, and you really, really, really want to do this, maybe come chat with a few of us so we can talk you down and all the things that happen to this. I couldn't think of a way to explain it real quick. So, NervesHub 2.0, interested in more, go there. Goals, first biggest goal was just getting more devices on this thing. So at one point in time, we're in like 10K range that we were thinking about. That's, that was nice. And now we need to think a little bit bigger, and there are a couple of changes that had to be focused on to fix that. So you'll see that. The next thing, how do you schedule firmware updates to be done out? So NervesHub did it kind of a simplistic way, which was great, works well. There's definitely much more sophistication that's really needed once you start getting lots of devices. Now, on the other end, a lot of NervesHub users turned out to just be hobbyists or like small companies. And all of a sudden, the whole NervesHub project was set up to be, doing a big fleet of devices. And that was a big hurdle if you wanted to run your own. So right now, Eric just published, and if you want to install it, basically it's scripted up. You can just run the script and go for getting it set up for a smallish distribution of devices. All right, so then let me just say, if you have more questions, Eric, wherever Eric is, over there, feel free to ask him or John. They have just done tons of great work on this, and it is totally used a lot. All right, so that's the 2.0s. Machine learning side. Okay, Totally not machine learning. But Livebook, I can't emphasize this enough. If you're coming new to Nerves, this is where you want to start because this lets you experiment. The Livebook project, if you're just looking at for the machine learning stuff that to use NX or Bumblebee or any of those things, you'll get a feel for how the thing works. It works basically the same on Nerves. The software just totally goes over. The project's called Nerves Livebook. You just go over, download it. From there, you can get the pre-built firmware. It'll just run. That's, I think, a bunch of us have been talking about a lot. I can't emphasize enough how helpful it is to have this notebook style. So, and basically, I would love to say I do a ton, but the Livebook team is so fast with adding features that basically all the innovation in Nerves Livebook is coming from there. It just rounds to that group. When you run it, you'll have access to just tons of Nerve stuff that you'll just be able to hit the ground running. I guess probably the hardest part now is just getting the board to run it on. And many of us will try to help you with that part. Okay, so machine learning. I've been saying we're starting for like the longest time, and that's true and false. It's like there's a lot of groundwork that we've had to put in the whole system just to support this, and like random things came out of this, like Zig support, and that is totally not obvious that you would actually get this stuff, but machine learning tends to like push the boundaries of the compilers and these other components that we use to build our system, and then all of a sudden, like, random things come out that are also helpful. So you can do this. I've done it. If you have a Raspberry Pi, you can put Bumblebee on it, select the simplest model. I think there's one like there's a text-to-speech or like some sort of summarization one. It works. Basically, I started going and then come back in a couple hours, and it gives me the answer. So kudos to Elixir and Erlang that this works, but it needs to be accelerated, and there's really nothing open source that you can easily get to accelerate these. You can kind of do it. If you're really into it, you can do it. What the Nerves project is sponsoring is work from Kokoshu. They've been doing just tons of work with eVision, so the computer vision stuff especially. All of you who have donated to the Nerves Open Collective, thank you. A lot of that supports a lot of hardware needs that we need. It's also supporting some of Coco's work. They're focused on TensorFlow Lite first. So TensorFlow Lite is a machine learning library that's really for these smaller systems, or at least it certainly works better on that. So we're starting there, and we have a lot of ideas on building upward. If the other ask that I have, if you're interested in this, you have camera or microphone support. We're currently lacking. Like a lot of the Linux libraries are there. The bridge to take it over to NX is not. And we'd love to get that stuff built in for when we start getting closer. All right, so here's a little demo. If you download Nerves Livebook today, this demo that I'm showing here is included in there. So you download Livebook, open up the TensorFlow Lite demo, and you can get the answer for what kind of bird this is. So, and you can do a lot more, and then I'd point you to Coco's website for the additional examples. Yeah, here. All right, so the last thing is website. Between, I don't know, late last year and now, I forget when, we totally redid the website, and you can see some of the changes. The main change has been on getting started. We want people to be able to just go to this website, get started with Nerves, and actually do something that is interesting right away. I guess I'll also point out the community-generated content. That was one thing that we didn't have as much posted on there, and now now that's a little bit easier for us to share. I think when it comes down to it, the Nerves community is all of us and others, and it was really important that the community content got shared there too. Last thing that I had was the new directory. there are about, I don't know, a few dozen projects. We start summarizing and putting them there. So anyway, when you get started, there are resources. There are new resources here. I hope that they help people who haven't used Nerves before. And that's it. So that's the core team right now. And if any more questions, just come find John and I are here. So just let us know. Thank you.